then, of course, this valuation was extreme, and now it's the valuation of SpaceX is the same like Boeing.
Yeah.
Although Boeing is making passenger aircraft, they're having defense and so on, but investors, they are defining the price. It's getting worse and worse and worse, and at some point the whole thing tips over, and then you cannot undo. It makes catastrophic changes.
Welcome to the InnoHives podcast. In today's episode, we sit down with Aron Lentsch, CEO of Orbspace, a Japanese startup breaking into the space industry by creating highly reusable rockets. Aron previously worked with the French space agency on the Ariane 5 rocket and is now focused on changing the way rockets are built in Japan by building his own Infinity rocket. During our conversation, Aron shares an incredible amount of insight about his journey, the challenges of rocket development, and the future of space exploration. If you're passionate about space, this episode is for you. As always, you can find links in the description below to learn more about our guests. This is the second episode of the InnoHive podcast, and your support means the world to us. Please like and share this episode to help us continue on this journey. We feel incredibly fortunate to interact with such inspiring people, and we're on a mission to share that inspiration with you. I've learned so much from that conversation, and I hope you enjoyed as much as I did. And now, Aron Lentsch. All right, Aron, thank you very much for joining us on the InnoHive podcast. We already had the chance to have you at our Inno Talks last time, but today we're going to be talking a little bit more in detail about Orbspace and yourself, what is Orbspace, and a lot of interesting things happening today for sure. Aron, before we get into it, tell us more about what is actually Orbspace.
Okay, so first of all, thank you for having me. It's the last talk we had was really nice. There were really many good questions, and so I thought continuing this talk
Let's do it.
is very exciting for me too. So what's Orbspace? It's a startup, and it's actually not just a space startup, it's a rocket startup. Rockets are a bit difficult to make. So if you look at the space scene, there's really many satellite companies, but not so many rocket startups, especially not in Europe and Japan. And it's about making rockets cheaper by making them reusable. And that's actually technically quite difficult, as you can imagine. Still, we have some ideas how to do it differently. And one of the things we are making different is we are here in Japan.
Why do you want to make rockets cheaper, Aron?
I think ever since the dream of spaceflight, rockets are the bottleneck to space. It's the cost. I mean, in the past it has been incredible, like $30,000 per kilo to go to space. Then think up 1 ton of satellites. So for decades it only paid off for defense, military defense, and then for broadcasting, where you put a satellite and you send TV programs. That was for a really long time the domain of space. It started to change a lot when satellites became cheaper because they could make satellites much smaller. Essentially, if you have the power of a smartphone, you have a small satellite. That's how CubeSats are essentially made. They are this kind of power you can put today, and it's keeping going smaller and smaller. So that lowers the cost. You can use a lot of off-the-shelf. So satellites are getting cheaper. And of course, still the bottleneck for rockets remains. There has been a big change when SpaceX succeeded to have Falcon 1 going to space. That was kind of the big disruption. Many companies tried before. I think most people are not aware how many decades it took for a private company to really make it into space with a low-cost rocket. Companies made it to space with private companies, but not really for such low cost. That triggered a wave, kind of almost a tsunami, especially in the US, like uncountable 200 startups, rocket startups, making what Falcon 1 did, expendable rockets. That means you use them once. And of course, making them reusable, like using like an aircraft, that would be the real change. But that's actually not as easy. And still, we have to think, we start a little bit late, if you might say, in the market. So we have to think next step. And that must be reusable, I think.
What will be the immediate consequence if we get to that point where Orbspace succeeds and creates those reusable rockets? Like, what is the impact in our daily lives?
Actually, we are looking at several markets. What I have to add in addition is that making rockets already is a huge challenge. Making them usable, even more so. So what we are doing actually, we make a first step. It's called a suborbital rocket. We are not the first one. The most famous one, Virgin Galactic and Blue Origin, they already succeeded. But again, the kind of trouble of space strikes back, the cost went up. It took much longer. Instead of a couple of years, Richard Branson thought he would just take Spaceship One, modify it a bit, and a few years later they had the plan to start flying. It took 15 years to get it there, and the cost went up. And now actually we are talking about $500,000 for a ticket price for a short duration space flight for Virgin Galactic, and $1 million for Blue Origin. And that's again cost where we are at a level where it doesn't really start the real market.
Yeah.
So one objective, one impact will be if we can achieve a smooth development, not spend so much money, then get into flying what we want, really high reusability. That would allow to really go cheap with the ticket prices. We are thinking like $100,000 is Miami in Japan, roughly. And not just that, also keep it producing. Because the second big issue for rockets is if you a startup like they are thinking like 30 flights per year would be kind of a dream number. Now imagine you make a really reusable rocket, you reuse it 1,000 times, use it 30 times per year, you make one rocket every 30 years. That cannot work either. So that's another catch, if you wish, of making reusable rockets. You also have to change the market. You have to make new markets. One market is human spaceflight. There might be many satellite companies and there might be a business, but I think the real big business is when you can carry humans to space safely. Another one is, and the even more pressing issue, there was just this big space conference, the Space Tide conference in Japan last week. Another big issue is space debris. It's enormous space debris, and the UN had a report just a couple of months ago where they declared space debris as one of the 6 key challenges of humankind. I'm trying to recall the name, how they call it, tipping point problems. It's like it's getting worse and worse and worse, and at some point the whole thing tips over, and then you cannot undo. It makes catastrophic changes, and that would happen if it's a domino effect in space would happen. It's like a chain reaction. If satellites start colliding, they did already 2 times, and there was one collision in space, one Russian satellite which exploded, and nobody at the moment knows why. Maybe it's the 3rd case. So this number of incidences where collisions happen in space are increasing at an alarming rate. If then these parts, thousands of parts generated in such a collision, trigger more collisions, the whole thing could escalate in a way that we generate so much space debris that we cannot actually use the low orbits anymore. That would be really a catastrophic event. Now the UN is trying to raise awareness. It's a bit similar like the CO2 problem. I think now you talk to everyone is now aware we have to reduce CO2. It's kind of the human challenge is we have to get away from fossil fuel. The same has to happen for orbital debris. Now, how can we do it? So many parts in space. We have to go thousands of times to space and try to catch things. One way is if we do it with infinity rocket, because if we have a rocket which can be flying 1,000 times and we keep it producing, we are thinking like aircraft production rates, 100 per year. Now then can easily calculate how many flights that makes per year.
Yeah. So those flights will be sent to pick up debris.
Exactly. So that's another very interesting application. There's more because once you can go to space very quickly, the rocket becomes like an aircraft. Not just in a sense that you can essentially launch it, because it's flying so many times. Our tanks, they don't need to be cooled. I mean, they keep being refilled. It's very similar to an aircraft. And that changes a lot the way how you think about the rocket and how to use it. You might launch other
But if we
things,
get to that point where those rockets are reusable and the trip to space is getting so cheap, don't we get first to a point where we have more and more debris first because we keep sending more and more stuff in space? Is that not the first issue we're going to face?
That's true. The point is, of course, yes. You have to make the rocket such that it doesn't make any debris. The current rockets, the upper stages remain in orbit. That's a no-go. The second thing is, it's also about sustainability. Rockets, especially solid booster rockets, they are extremely polluting. I think we have to really get away from that. In our case, we're using methane, biomethane. And biomethane is actually the only fuel which can be generated really biologically. So it would be almost 100% sustainable.
I mean, I'm pretty sure most people don't know about that, but who makes up those rules? Like, who decides how much you can, leave debris? What are the rules? Who decides? Who owns space? Like, how does it actually work?
Yeah, it's a very good question. Actually, there is international space law. International space law started to be set up at the point when actually space became available. So we are talking like the 60s, late 60s, early 70s. Russians and Americans started to achieve this level of technology to reach Earth orbit. There was still a Cold War going on. There was the race to the moon, right, in the 60s. Then there was one concern, is what happens if my capsule comes down on Russian territory, my astronauts? And the same for the Russians. So they had a real need to discuss. At that point, they established what is called the Office for Outer Space Affairs of the United Nations. And one of the first rules was the return of the astronauts. So they developed 4 treaties, international treaties. One is the rescue agreement. So if cosmonauts come down in US territory, they will be sent back with their capsule. So they don't touch it, we don't get the technology, just we take it and let them go back. Actually that happened, it's another funny story, but it's another. The other one is the so-called registration agreement. So to just have a number. If you have a satellite, you have to register it, and you have to tell this is the orbit, it's flying there, and it has these numbers, and it belongs to me or who else. Another one, the third one, I'm not mixing up the numbers probably, but the third important one is the liability convention. If a satellite comes down, falls on your head, who is responsible? Who will take care of it?
Right.
The fourth one was agreed, but
wait, who is responsible?
Yeah. Okay. Very interesting. It's always the states, because at that time the only bodies who were making spaceflight were the states. So essentially, it's the state who is launching a rocket who will take responsibility. The funny thing is now we're talking about private spaceflight. Yeah. So if I'm going to space, I'm a private person, but still it's the launching state. And that is even more difficult because I'm Austrian citizen. And actually, if I'm running the company, even if I'm launching from Japan, what counts is the citizenship. It's quite weird. It's a very weird part of this space law. But anyway, it's the state. Who is responsible.
So in your case, Austria will basically be...
Might be. It's quite unclear actually at this point. It's quite unclear. It's interestingly legally unclear because nobody thought that, there would be a private person launching to space. Everybody thought it's the state, it's US, it's China, it's Russia. Yeah. And the fourth one, it's also very interesting in the context of a discussion about space resources. Like there's many companies now trying to go to the moon. It's the big... If you take something from the moon, it's a celestial body. Does it belong to you what you take there? You find whatever you're looking for. You take it back. Does it actually belong to you? And this fourth space treaty, it was actually never ratified. The nations agreed, but then they never ratified, so it never actually came into action. And there's big disputes about that, because it would also regulate these aspects of possession and appropriatory aspects of space. So it's simply it's very unclear. Now, independently nations like US, Japan, to keep still going, they started to make a national space law and some kind of national agreements, but it's not really international. So, usually it should be international space law agreed by all nations and not just a few. So it's very unclear at this moment. That's the 4 treaties. They are regulating, but they do not regulate anything about space debris. Yeah. If you lose your satellite, it keeps flying around and it makes some trouble. It's very unclear what's happening, especially it's fragments. Who can say that this fragment afterwards struck another satellite? So, if it might fall down and fall on your head and you can prove it's from the satellite, that's another story, right?
Are there like any rules like before you can get into the private space industry? Like, what are the barriers? Like, is it just money, or like, are there like, how does it work?
Now you're talking about generally if I as a company want to become a player in this economic field.
Exactly. Yeah.
If you're looking from a satellite point of view, actually not. Now there is international space laws who regulate if you want to launch a satellite, you have to get a launch permit that you get because of the rocket. And if you're then in space, you have to have an insurance coverage. So that's pretty much covered. So because this liability convention is in place, right? So and then the states, the launching state, where you and everybody is a member of, they are regulating with national space law how to handle that. Like Japan, for instance, would require you to have an insurance if you have a satellite with this amount, and you can negotiate under certain conditions. If it's a very small satellite, the premium can go down. We are talking, for instance, with one of the largest space insurance companies, Mitsui Sumitomo, Kaijo. Because also we need to insure our rockets, so we are discussing with them. It's very interesting because since 30 years they are in space business, entirely private space business. Not so many companies actually since 30 years in really private space activities. So if you want to get into space, to come back to your question, if you want to make a satellite, it's pretty easy going, it's no trouble. If you want to make a rocket, it's a bit more complicated, especially in our case. We want to make what is called a suborbital rocket. So it's a rocket for short duration space flight.
Right.
It means we don't actually get into an orbit. The difficult part of space flight is to have the speed. It's not the altitude as many people would think. It's actually the speed, and the speed it's a horizontal speed. You can think like a cannonball. You have a big cannon and you shoot. In order to stay in space, what you need is actually you need to shoot rather horizontally. And you have this kind of parabola. And the bigger your cannon could be, it would be more and more parabolic. Eventually, if this cannonball has the same curvature of the Earth and is high enough to be outside the atmosphere, to not be slowed down by the atmosphere, eventually this bullet would keep flying around the Earth. And that would be the speed of 8 kilometers per second. That's called the orbital speed. It's difficult to imagine, right? 1 second, 8 kilometers.
Yeah.
In kilometers per hour, we're talking like 25,000 kilometers per hour. To give you a perspective, an aircraft cruises about 1,000.
Right.
So you're 25 times faster than a normal aircraft. That is the difficulty, the technical difficulty of rockets is that. So you need this high speed. And if you don't have it, you come back and then you have what is called a suborbital flight. And that's what we nevertheless were looking for as a first step, to avoid this extreme challenge of having very, very powerful engines in very low weight.
How far is Orbspace to achieve that, like to achieve the reusable rockets?
Yeah.
Like how far are you? What are current like challenges, the bottlenecks? Like what's the current situation?
I'm coming from governmental rocket development. I've been part of the Ariane rocket development in the past, and actually working on the next generation of Ariane rockets, what is now actually Ariane 6, and luckily the first flight was a success after 20 years of development. So I'm coming from this kind of corner, not maybe not the typical corner of startups. And I've been working on reusable rockets, so the way I'm designing Infinity is in the same way, and the point is you don't start with hardware. And that's a bit chasing and making it difficult, because usually investors, now we are looking for investors to fund they want to see hardware. That's what they really believe. If I come with a study and I say, okay, we looked at that, we made simulations, and okay.
That's what they can see.
That's what they can see, that's what they trust. But to come back to your question, where we are, we made several analyses. We made several technical developments, what I call some kind of exploratory developments. A rocket needs not one technology, it needs many. And you need to make sure that each of this technology you choose, you can actually do it, you can achieve it in the time and in the budget. And that's actually the really tough part for rockets. It's a big management challenge. And the biggest thing is what most companies most difficult is to tell, I'm making this rocket engine and I can do it in 3 years and with this budget. Most companies fail like that. So this is where we spend most of the time so far, is to analyze and to make some small tests and some small experiments to make sure that the thing we want to develop we can actually do. And we gave up some of those. For instance, we were looking into laser ignition. It's very nice to have a laser who can ignite the rocket engine. We gave up because we found that the electronics we need is currently the size of a small hi-fi with maybe 10 kilos. So you don't want to carry that around. It's not reliable either. So we made this kind of analysis. We also made economic analysis, some economic optimization, because reusable rockets is not just a technical challenge, it's an economic challenge. And the space shuttle is actually one of the sad examples for it. People were only looking at the technical challenge, and in the end, it turned out it became much too expensive. So from the beginning on, you actually have to design the rocket to be also economically feasible, not just technically feasible. So we worked on that a lot. We made, together with the German DLR, the German Aerospace Center, we made some optimization, some simulator, some business simulator, where we combine the technical things, like the size of a rocket and the payload and the seats, development cost, and then how or which duration are you going to pay that back? What is your assumptions for the market? How often do you fly? What would be the cost per flight, the maintenance cost? It's very simple.
What is the current cost per flight?
Yeah, the current cost per flight, what we are aiming in the beginning, is something like 300. Okay, the cost is difficult. The cost, I can tell you the price that what we would charge to the 3 customers. 100,000 per flight, kind of the old number 20 years ago. That's what we are aiming in the beginning. So that makes $300,000 per flight. Of course, the cost will be lower, but that's kind of the true cost. What I can tell you, just to give you an idea, the cost for the propellants to kind of fill it up is just $2,000.
How much will it cost to build the actual rocket?
Yes. The approximate cost, because that will change a lot with the production.
Right.
The first unit cost, we are going for about 12 to 15 million US dollars. Yeah, that's the first unit cost. You can think like a business jet. It's like a relatively large business jet would set you back like this number. Although that's the purchasing price again.
Yeah.
So what I'm telling you is the cost.
Yeah.
So again, there's this big difference because all the profit and with each time you're producing it, the cost go down. There is what is called the right learning curve. And when we produce it 100 times, we are at about half the cost. And if you keep producing, it's kind of this shape, it flattens out. That's one of the key points. If you can keep producing, you really lower the cost.
Makes sense.
Yeah.
Like we off camera, we were talking a little bit about SpaceX and like how did they manage to actually get to where they are? Like, what is their cost? How much do you actually know about that?
Maybe technically how they could manage actually is, well, first of all, one of the key things SpaceX does is to make things simpler. If you listen to Elon Musk, what he's actually telling, he even invented a word for it. He calls it undesigning. So he wants to make a rocket simpler. He wants to take things away as much as possible, because anything you put on a rocket, you have to make it reliable, you have to design. Somebody has to sit down, make calculations. If you want to make it cheap, try to remove it entirely. That's what he called undesigning. A big step was to make things much easier. In the beginning, some people were even laughing how simple he made, because he didn't put so much effort in making a nice combustion chamber. It made a really black smoke. Everyone was laughing, ha ha ha, but he could make it cheaper. And because he could make it with his own money, the entire Falcon 1 was paid by his own investment. That, of course, put him in extremely favorable position now when he then reached out to venture capital to set his company on a larger scale. Then he already could say, look, my rocket is already flying. And then, of course, his valuation was extreme, and now it's it's the valuation of SpaceX is the same like Boeing.
Yeah.
Although Boeing is making passenger aircraft, they're having defense and so on, but investors, they are defining the price. If they are paying that number, the price for a share,
Yeah.
that defines the valuation of a company. So this means the expectations of SpaceX are extremely
So
high.
because he has a proof of concept, raising money becomes easier. But
Exactly.
he was the one financing it. So like,
Yes.
so the barrier to entry is actually
Yes.
really, really high.
Exactly.
in that
And
sense.
today it's a bit similar. For myself, is finding an investor who would believe what you're telling.
Yeah.
And Elon Musk also couldn't find one. So
Yeah.
he had to actually prove it with the hardware to say, okay, now you believe me, I can do it. Today it's of course a little bit easier because everybody wants to follow. So there are investors, especially in the US, investors are very challenging. That's amazing. That unfortunately is different in other countries.
Yeah.
Investors are not so easy to put down $1 million on the table and say, okay, go ahead and show me what you can do.
Yeah. What will be the future? Like, how quick will it get? Like, if tomorrow you raise the money that you need, like, what happens? What are the next steps then?
I mentioned before, Ariane 6 development took about 20 years. No investor would give me money if I say, okay, 20 years, it's a no.
Right.
Other companies have shown that they can be extremely fast. And it's kind of a culture of thinking. If you look in other sectors, one sector in particular, which I really like, is the racing sector, the F1 race car development. Why is it so interesting? Because they have 20 races per year. They are moving around. They are building their car by themselves because actually you cannot ask companies to build things for you so quickly. So most of the racing car companies not only design the cars and develop, they also build it. They have they have a machine park. That's the way how they can be extremely fast. Fast means cost, because cost for space is the number of engineers you have to pay. The engineers in the facilities, that's your cost. And if you have to pay 20 years for 10,000 engineers, then we come up with the cost of development of Ariane 6. It's very, very simple actually.
If you raise the money that you need, what happens to Orbspace?
Yeah,
basically.
yeah.
Right?
So it's actually the engineers.
Yep.
The cost for rocket development is engineers. And the facilities, but it's 70-80% is engineers. So if you keep paying 20 years for Ariane development with 10,000 engineers and more, that's you can easily add up.
Yeah.
That's the development cost. Yeah.
How many engineers would you need, do you think?
Similar to this analogy to the automobile racing teams, they have the smaller ones, about 100 engineers, 100, 150. The bigger ones, 300, 500 in this order, in this size. Yeah, that's the whole point is if we want to make it low cost, we have to be fast. Not 20 years, but 6 years. That's what you asked before. The time it will take for us will be 6 years. Again, Elon Musk did one thing. He didn't make many mistakes, if at all. That's kind of from an engineering point of view.
Yeah.
And engineers like to find mistakes because they want to avoid them. Looking at other companies like Virgin Galactic, they make many mistakes. That's why I actually wanted to make my own company, because from a rocket engineer's point of view, with that many mistakes, they cannot succeed, I thought. So there's many ways to make it better. Blue Origin did it better. They did a much better job. Still, they're using hydrogen, for instance, as a fuel, which is very dangerous. And dangerous means that you have to spend so much more effort to make it safe. And it can never be really safe, in my opinion. So also there's many things to improve.
Yeah, I guess for you, like having that hardware will make it easier to raise money to get to that point. But how much can you actually do through simulation? Like like you can probably do a lot through the simulation, which then you can probably test a lot of things as well out.
Exactly. Simulating is now people invented a new term. They call it the digital twin.
Right.
Now, you know, when you're from rocket engineering, you basically, since 20 years, we are making digital twins. We are making models, and this is not easy, especially if you go into the details. Like the key challenge for rocket engine is what is called combustion instability. In a very simple explanation, if you have a candle light, you don't have any noise, right? There's no, it just burns.
Yeah.
If you if you put more energy, like a small torch flame, you start to hear some noise. because the flame, if you look at it very carefully, it starts to moving, and the more energy you try to convert, like if you put pure oxygen and maybe liquid oxygen, like in a rocket engine, the more energetic, the more things start to be unstable, and this kind of expresses a bit of difficulty, because this instability can cause really a lot of trouble inside the rocket engine. So you have to understand what's going on, how you make the injector, the tiniest changes of the production. Some rockets in the past were lost because they forgot to take away some, how you call it, at the edge during manufacturing you have a remaining metal, and it forgot to take that away. It's no joke.
A small detail.
It became unstable, the combustion inside the combustion chamber, the engine got lost and the rocket got lost. So with simulation you can do a lot.
Yeah, but like that kind of small details you cannot. That's just unpredictable
exactly
stuff.
So that's exactly, so you always have limits. But you can make it, even on the larger scale, you can make it so stable that even then tiny mistakes, like in the production, they will still not make the whole engine unstable.
Does AI, like, I mean, now all those LLMs, and is it helping towards getting closer and closer in detail-wise to that perfect simulation?
Very nice question. Actually, I'm sometimes feeling I'm getting old, because because when I'm hearing these new ideas, then I say, oh, hang on. There is a lot of benefits. If you, for instance, make literature research, you try to find what's out there, looking through patents, for instance, there AI can help a lot, I think. Generative AI, where you really let AI design something, I'm a little bit still reserved. I think where AI really pays off, if you automate simple things, especially repetitive things. If you can make a flight control system with AI, which can find solutions to get back to your flight path and so on, that I totally believe in. Designing rockets with AI. So generally, I would say let AI do rather the less intelligent, let make AI a replacement for the less intelligent jobs, not the highest intelligent jobs.
Right.
Maybe eventually, maybe in 20 years, AI will get so intelligent that they will also replace engineers.
How accessible is like that kind of data? For example, like, you know, SpaceX producing all those rockets now. Like, how accessible is that kind of data? Because the more it's accessible, the better the AI will probably get for other people as well.
Absolutely. I mentioned patents. That's one source of information which is quite important. That's why actually many companies do not patent their technologies, because they don't want to let other ones to share. Another thing, of course, there's research, and especially just what I mentioned, this combustion instability. That's research, and research is open. By definition, research is, with exceptions, of course, is open source. So you share, you meet other scientists. There, AI can certainly do something.
Makes sense.
To help, basically, a quick overview, some ideas. But I tried for patents, and AI for the moment does not do is, if we are communicating and I'm making, you don't understand my question, you would say, your question is kind of doesn't make sense. AI never does that.
Yeah.
It just gives an answer.
It understands everything, and
understands everything.
Doesn't matter if it does. That makes sense. And it kind of makes sense that those companies don't put everything public. I mean, it's so expensive like that. Like, software is cheap, so I guess the open source culture is kind of easier to get to. But like, when it comes to like producing that kind of hardware, like the quality assurance is extremely expensive, testing stuff. So it kind of makes sense.
Yeah.
So what will be like right now? How many people in Orbspace? There's you. How many people are actually in the team?
Yeah, we are 8 at the moment, but we are still looking for seed funding.
Right.
So
what will be the first type of engineer that you will hire if you have the funding?
Actually, we mentioned some of those simulations.
Right.
Classical mechanical or aerospace engineers who has a good background in rockets, who can really help to set up a test stand. You mentioned almost everything. Testing is the key for rockets. So what we are looking at is setting up a test stand quite quickly. We are looking actually not just for engineers. We really need people who can build things on machines. So in classical terms, we're looking for half blue-collar workers, people who can really operate machines, and half engineers.
That is hard. So I specialize in recruiting for the robotics industry.
Yes,
I do a lot of space companies as well. Are you, like, for example, for the simulation type of profile that you look for, would you be open to talk to people in the robotics space, for example?
Totally. I mean, if you look into the details, if you're making a rocket is a robot drone, except that it has rocket engines and it controls the valves, but essentially the engineering is the same. So the skills you need for programming, we need to program, of course. Safety programming. There's actually new programming languages coming up, which is very, very interesting, and which typical safety engineers do not know. But I believe it's this kind of new type of programming languages.
What is the programming language you?
One is called Rust, which I like very much. It's very similar to C. C is still the most used programming language for also safety applications, but Rust has a very good additional safety layer. So that would be something I would be very interested.
Yeah, it's some companies in Japan are trying to hire more and more people with Rust, and it's almost impossible to find people in Japan. So a lot of companies kind of give up to switch from C++ and C to Rust just because of that. So it's I mean, hiring in Japan is very, very tough.
I can imagine.
So, like, are you always open to have a casual chat? Because a lot of people want to transition from for example, robotics to drones. Like, how does it work?
Absolutely. Passion for space is very important. So I'm looking certainly for people who really want to become part of a team, who making a next big step forward, people who want to be part of a team, company who changes things. That's why I started making rockets, because if you're young, you want to change something in this world. And I like engineering, and I thought now is the time for rockets. And this is what I'm expecting actually from every engineer, that he's joining my company because he wants to make a change.
What is your dream when it comes to the future of space flights, and like where do you see it being? What is your absolute dream actually?
The absolute dream is really, it's a bit difficult to express, but can you imagine the time when we had small wooden ships crossing the Atlantic? And most not coming back because they got lost in storms or whatever. I mean, the Vikings, we know they could make it across. We are a bit more for space than the Vikings at the time, but the dimension is still the same. We are building tiny rockets because it's still not that easy. If you think about the cargo ocean ships, 300 meters long, 50 meters wide, it feels so normal. They're just cruising with a small number of crews. That's my dream of space flight.
There's point A, point B, and there's no uncertainty.
And nobody cares anymore how you do it technically. It's just flying. It's flying reliably. And there's space stations and there's moon stations, and everybody thinks it's granted because it's always been like this. The interesting thing is, things change so quickly. People, recently I saw a very nice presentation where somebody showed a photo of New York in about 1900. And the same exactly scene of this photo 20 years later. And the difference was, in the first photo, everything was these horse coaches. 20 years later, only cars. So within 20 years, the world changed entirely. And one of the reasons is the electric starter of cars. When it became possible to start a car engine by just pushing on a button, then it became accessible for everyone. And the prices also went down, of course. Prices is the key issue. But when it becomes usable, safe and reliable, then it becomes a big market. Then everybody wanted to have a car. The same will be true for space. It's at some point, and this point will be quite soon, I believe, we will all see that.
How soon do you reckon?
20 years. Might sound long, but I mean, we will enjoy going to space.
It's quick.
At the conference, this Space Tide conference, there were 3 companies who have funded development of space stations.
Which companies?
Private space stations. One is called VAST. Okay, well, probably don't call all the names. But it's now there is the spirit of now or never. If you want to be part of space station business, you have to do it now. And the funny thing is, they don't even have a clear business plan. There was a question, what's the business plan? We just go for it.
Yeah. Why that sentiment of now or never? Like, what is happening that causes that kind of sentiment?
I think you have to be now in the position that you set up the market, set up the customers, because afterwards you keep developing, you make it bigger. And a late entry in the market might be too late at this point. That's why people think like this. Maybe not, because of course from a rocket engineer's point of view is the same way like SpaceX is building now huge constellation, the Starlink constellation.
Yeah.
If you are in the position of the rocket, you can do anything actually, because the most complicated and most difficult thing is the access to space. You can, I think SpaceX will make a space station if they think. One big topic now is computing centers in space. And why you want to do that is because you have continuous energy. Computing centers are consuming a significant amount of electricity. We are talking like worldwide consumption of electricity for computing centers is like the entire electric consumption of Japan.
That's crazy.
That's crazy. If we can put these computing centers into space, we have free energy from solar cells, from solar panels.
Yeah.
The heat can be radiated away. It's just the question who can start, and the key question, of course, it's this huge installations. So somebody has to carry that to space to make it sustainable. You have to make rockets sustainable, so that sustainable rockets can carry up all this mass, so that these huge power centers actually can be a can make a benefit for carbon neutrality. But that's very concrete. I mean, there's a clear need that the space stations would be there. It's very safe because there's little risk of terror attacks and things like this. There's not one, but many. So that's a very, very interesting business case, I think.
Like, will your situation be a lot easier if you were actually, not a private company, like actually a public company, for example? Will things be a lot easier in that sense? Like, where you have quicker money, like all those, like, how much will it accelerate if suddenly the whole space industry becomes actually public, for example?
To become really public, like a step back into the past, it's very difficult to imagine, because it's this private step who actually reduces the cost. It's having competition. The key point is actually competition. Why in the 60s space went so quickly is because you had this competition between US and Russia. And it's the competition who speeds things up. Public is very important, but not as in the position of really having public companies who are developing, but as customers.
Yeah. But a lot of private companies are getting government grants and like support, right? Like, so how much faster will those companies grow and achieve their goals if they were receiving more grants from the government, for example?
I would even put it differently. I would say it's a necessity to have government funding in order to be not only faster but competitive with other countries. I mean, US and NASA is putting so extremely much money into SpaceX. The cash flow of SpaceX, if you look at it in detail, most of money comes from NASA. The real cash money. Of course, they're selling their shares. They're getting money from investors, but the tremendous amount of the real business, the selling rocket, comes from NASA, because if you look back in history, it's actually NASA who had this entire idea to combine space development with venture capital. It's NASA who hired consultants who then came into NASA and tried to teach everyone how it works, what venture capital is, what is innovation. It started from there. The head of NASA, Michael Griffin, who was just the person who put all this in reality in NASA, he was head of a venture capital company before. And he facilitated, I mean, it's not the only one who did that. It's not one person, but you can see that the importance. So yes, to come back to your question, it's tremendously important to have public support. And in every country, a country who would not try to foster rocket startups then they will not be competitive. They will not make
How competitive is Japan? Because I mean, for example, we can see a lot of startups, even in the software space or like AI, they struggle a lot to raise money. You know, the VC like space here is quite small compared to the US. And so how well is Japan positioned, and are they actually making progress now? Are they changing their mind? Are things going in the right direction?
That's a very good question. I have to be careful as a foreigner not to be critical.
Yeah.
Okay, let's put it from a positive point of view. Japan still has recognized the importance of venture capital and how this private spaceflight is really revolutionizing and disrupting, really disrupting in a very core sense. As maybe I tell that first, what actually means disruptive? There's several definitions, but the one I like most is if you topple the market leader. And that's exactly happening right now with SpaceX, Boeing, Lockheed Martin. They're almost gone. Now SpaceX is the launcher company. That's disruptive. And the same for satellite businesses. It's totally disruptive. Japan understood that, and they're putting some effort. I wish they would take more risk.
Yeah.
Venture capital means taking risk. That it's very different from the traditional way of space development, where you try to plan for years. You have a really good plan, and then you have the agreement of everyone, and then you put money, and usually a lot of money, and then you really have to make sure it really works. So you have to make very small technical steps. Venture space development is different. You put money in a company with a good idea, 1 million. Let them show what they can do. If they can achieve the milestone, you put more money. It's not that you plan everything. The really big thing is you go into it, you do it, and you do it with many companies. As far as I can see, in Japan, it's still that classical way. It's government tries to decide who gets the money, tries to pick the companies beforehand, rather than just trying to put little money in many players, like NASA did,
and support the industry.
Put them into a race, support the industry, support the growth, the establishment of companies, exactly. So what's missing today is to really help companies to get started. In Japan, companies get a lot of money if they are big. And I'm not exactly sure if this is such a good idea, because only because they are big doesn't mean they are really that excellent.
Yeah, Aron, I could go forever on this. Like, this is so interesting. But like, maybe a last final word on your end. Like, what would you like to say to the audience that are mostly engineers? Probably most of those engineers are interested in space industry. Like, what would you like to tell them? Like,
We are living in totally exciting times. You say engineers, but I even want to address those who are thinking to become engineers. Do it, because in the next lifetime of an engineer, it will be so exciting. We will have so many things going on. And yes, I think having dreams and trying to make things, I think that's the people I really like to have in my companies, people who like to build things, to make things. It's nice to be a scientist, but the people I need in my company is people who really can make things. We talked about the simulation, making a robot. The nice thing about robots, you can buy the parts. It's getting there with rockets. Satellites, there's online shops to buy satellite parts.
Really?
Not led for rockets, but we are getting there, you know. This means we are going to speed up everything, because you can buy the parts. It's going to be totally exciting. And this is the people I would like to have in my companies, those who really make things.
Aron, thank you so much for the talk. It's been so much fun. Everyone that's listening, have a chat with Aron, find out more about Orbspace, and thank you so much.
Thank you.
It's a pleasure. Thank you.